Welcome everybody to this webinar. We just wait a few seconds to give everybody the chance to log in. So we have a lot of attendees today. So we just wait a few seconds so that we can see if everybody is out of the lobby and in this presentation. So a few people are logging in. Okay, thank you. Welcome to this webinar of IsoHemp, and also welcome to the world of the carbon neutral world and the world of hempcrete and hempcrete blocks. So we have today a lot of attendees, and this shows again that the interest of bio-based materials is still growing all over the world. So we have a lot of attendees from all over the world. And because we have, there are a lot of attendees, I would ask to not interrupt, but to ask your questions in the chat, and we will answer them afterwards. So then it's more practice. During the meeting, we will also try to answer the ongoing questions, but please, the questions in the chat, and then we will answer them afterwards. So my name is Dirk van Impe. I'm export manager for IsoHemp, and today we have two hosts. Also, Julie Badamy is present, and she will present herself in a few. So she will also do the first part of the presentation. So now I give the word to Julie.
Yes, thank you, Dirk. I will let you deal with the new participant. So welcome everybody. Thank you for being here today. So my name is Julie and I'm working at IsoHemp as a sales assistant for the export. So all the countries that are not Belgium friends. So for the sales matters and also for the marketing. So I will start with the small summary to show you what we are going to talk about. So we are going to introduce you the context and the IsoHemp history. And then we will show how we actually make the blocks. Derek then will talk about the technical aspect and properties of the IsoHemp blocks, and of course present the application. And finally, we will talk about we will show you some real life example, and we'll conclude with maybe small Q&A session because as Dirk say, we are very in a number. We are many people today, so maybe ask your question during the presentation through the chat, and we will try to answer as good as possible. Okay, so the context and IsoHemp history. So of course, the construction sector is at the center of climate emergency, and this is not a secret for everybody, and certainly not for you all. If you are here, it's because you are already concerned by these topics. It remains that we need to talk about this today and present you why we want to build with hemp blocks. So Belgium is a small country, but yet the figures are impressive because we see that we have 21 million tons of waste a year in Belgium. There is also 13% of Belgian CO2 emissions caused by residential heating. This shows how important retrofitting is. And today we are also seeing a real change in mentality simply because heating is becoming unaffordable. And we also talk always about the car or aviation sector and industry as very polluting sectors, but with more than 7% of global CO2 emission. The construction industry is actually one of the biggest responsible for global crisis, where aviation is around 3%. So this means that habits need to change, and it's pretty clear that we cannot continue building like this, and that we want to keep our planet safe for future generation. So building for future, that's what we believe in our company IsoHemp. We believe that sustainable construction is the key for greener future. With three aspects, by choosing sustainable and bio-based materials, by focusing on the circular economy, by recycling and also upcycling as many materials as possible, and focusing on the short supply chain. So yes, we focus on these three elements, and we will explain during the presentation how we make them happen in our process, and to build environmental friendly homes to answer the global crisis. And our first hemp block was born 12 years ago. So the blocks are made with three natural elements: hemp, lime, and water. And the blocks are all natural, recyclable, and locally sourced. And we can build and renovate now with carbon neutral homes with incredible thermal, hygrometrics, and acoustic properties. So that turns an efficient home into a naturally efficient home. So let's talk about our superhero, the hemp, because this is the basis of our blocks. The first evidence of hemp culture goes back 12,000 years ago. And throughout history, it has always been one of the most important agricultural products. It is, of course, the same plant as cannabis, but the part used for industrial application is different from the THC part. And this confusion is responsible for the bad reputation that hemp had for many years. And it's a shame because this plant is very extraordinary, because every part of the plant can be used, whether for making clothes or paper, sails, blocks, and much more. For example, the sails of Christopher Columbus boat were made in hemp fibers. The first Bible was printed on hemp paper. So it's a very old material. And in the early of 20th century, the paper and the cotton industry began to see hemp plant as a competitor, and they wanted to find a way to get rid of it. So they create the cannabis story as the very bad drugs, and this put the hemp in a bad reputation. But fortunately, recently, the plant started to gain recognition again, and it's because of its wide variety of different uses and potential to fight climate change. So the hemp, again, it's very good because it's a very carbon balance. And the plant also absorbs 4 times more CO2 than a casual tree. And we also don't have production loss because all the waste is reused. So we recycle production loss and make sure that this is reused in the next cycle with almost 15% with no loss of quality. So we, of course, as material have lime, as I said earlier, and we have a very big storage capacity. And it's a mix of air lime and hydraulic lime. Air lime will harden with contact with air, and hydraulic lime is activated by water. So we add also water in our mixing process. So we also have no water loss because we have a treatment system to clean the water that has already been used. The hemp is separated from the cleaning water, rough filtration, and the lime is held in suspension in the water and then re-injected into the mixture. And on the big roof of our company, we also have a rainwater collection cistern. So we don't need water from the network. So the story of IsoHemp. It begins 12 years ago when Jean-Baptiste and Olivier met at university. Both future engineers came across with the idea of revolutionizing the construction industry by making natural buildings and with hemp blocks. And they decided to develop their thesis project around this topic. And so IsoHemp was born. So thanks to hours spent in their garage studying, testing, experimenting, they were able to confirm their intuition and become fully aware of the thermal, acoustic, and hygrometric properties of hemp. And all that remains they were convinced they needed to convince the rest of the world. And to achieve this, it was essential to make hemp easy to use because the hemp was already used in insulating materials at the time, but it was not very practical to use. So that was the biggest challenge, and this is why they decided to create blocks. So in 2012, they were already pressing their first blocks by hand. So that was very artisanal, traditional construction building. And in 2013, the first IsoHemp houses began to see the light of the day. And after that, a third young engineer joined the team, and his role was to develop the process to improve the quality of the blocks. A year later, they moved from the garage to the first industry, still in Belgium, in the French part of Belgium, near Namur, if you know a bit Belgium. In 2016, they expanded their business from just renovating to also building with hemp blocks. And they created the Hemp Pro system, which could also be applied to other systems that Dirk will explain later on. It's also very important for us because we had the ATG certificate in 2020, and this gave us the much needed technical recognition of our product, which of course gave us a lot of credibility for the sector. And this was a technical improvement of the product. It's due to the technical improvement of the product. In 2021, they opened a new factory that we call Factory 2.0, which is also much more professional hemp block creation and increase our production capacity to 1 million blocks a year to 5 million blocks a year. So now we have a very good production capacity. And with the development of everything, we also affiliated in France in 2022 and opened an office over there. So we have also a team of 6 people working from France. So the process, this is the biggest question of everybody. How do you create, how do you build, how do you make the actual blocks? This is thanks to our unique factory. It is new since 2 years, and it's all automatized. So the process is pretty simple. So as I said before, we have 3 raw materials that are natural, and 6 key stages. So let's go for the overview of the process. So the materials, hemp, 80%, no production loss. All the waste is reused because we can reuse the hemp, as I said before, to re-inject it in the new cycle. We use 20% of lime, so 9% of air lime and 11 of hydraulic limes, and water. And still water can be reused and everything. So the first step is the mixing. So we put the all 3 elements together with a specific quantity, and we have an optimal control of the dosage of each raw materials, and this is very important. And we have a capacity of mixer of 2.5 cubic meters per batch, with a cycle time of 3 minutes or more than 2 pallets. So 3 minutes, and then it needs to go directly to the press, where there is a control done. And many years of know-how enable us to achieve this new development with the aim of producing calibrated product adapted to strict construction standard. So this step is very important, because this is the stage where the block has its form. And we are able to produce 1,000 blocks per hours, which represent 180 square meters, which is almost 5 houses per day. Then we have the hardening process. So we left the blocks hardened for between 8 and 24 hours. The work is completely automatic. We have machine that grabs the blocks and put them into ranges to let them dry. And it alternately pick up the oldest blocks that are already dry to make them go to the next step of the process, which is palletizing. And also very important, we don't have a heating process. It is all natural drying. So the room is designed to let the air through, and the ventilation is natural. And we only have a ventilation for the humidity when needed. The next step is palletizing. So there is also the last quality control is carried out before palletizing, and the pallets are also stabilized and protected. And again, it's all 100% automatic, and the speed of more than 250 boards an hour. The drying. So we leave the palette outside. So lime is very slow biter because he has to take the carbon back in the air to become a stone again. So the process is called carbonation. This means the lime capture the carbon in the air to harden again and to regain its limestone state. It's only cover it for rain and just dry with air and sun. It's 100% natural system because it's no need energy because it's outside and just drying by itself. And then the blocks are, after almost 3 months, are ready to be delivered to your lovely place and to go to your project. So now we are going to talk about the technical properties. So I will let Dirk present the technical aspects of the blocks. Dirk, your microphone is not on.
Sorry.
Yeah.
Thank you, Julie, for your nice presentation. So I will go on from this part. So let's go more in the deep with the properties, and this is all about why should you use separately from their environmental properties? Why should you use our blocks in your building environment? And it obviously sounds good to tell that hemp is, but we have to look also. It provides separately from their the environmental properties, also a good thermal and acoustic insulation, natural moisture control, and also an excellent fire resistance up to 2 hours. And as mentioned, it is 100% natural, which ensure a very healthy living environment without volatile organic compounds. And it's a good protection. Let's talk about that carbon neutral material. The carbon block. So as Julie explained, during the hardening of the carbonation, it takes back carbon from the air. And also when the hemp grows, it takes a lot of carbon. When a plant grows, it takes carbon from the air to go to in the bio-based material in the mass. And if we take in account the energy used to produce lime and produce the blocks, and we subtract all the carbon taken back and also the carbon taken by the growing of the plant, we come to a negative balance. And this means per square meter, it's about 20 kilogram negative. And this is very unique because if we compare it with other materials, you see wood, wool, cellulose, glass wool, they are all positive, and also concrete due to energy to produce cement, the terracotta blocks, so the brick stones, they use a lot of energy, so they are all quite positive. So this makes it very, very unique. So let me also emphasize that our hemp blocks are an affordable solution and only also become more and more affordable. First, we have a very extremely energy efficient factory, as Julie explained. Secondly, building it with our blocks is very fast thanks to the limited weight of the blocks. And in the long term, and this is more relevant than ever in these times, it will also significantly reduce energy bills thanks to the exceptional thermal insulation offered by our blocks. I will explain it more in detail. If you look at our building environment, we ask a lot of our building environment. It should be fire resistant. It should be mold free. It needs an efficient insulation, and we also like very good indoor air quality and an outstanding comfort. And nowadays, if we talk about an efficient building, most of the times the focus is on energy, especially the thermal resistance or the U value and the thermal conductivity. And this is all to do with energy saving of the building. But the healthiness of the building, energy and carbon costs at production time in a climate are often not taken into account. And it's our goal for tomorrow, energy efficient and healthy and breathable buildings, and if possible, with a negative carbon footprint. So this is our goal for the future. But today the systems are in a twinning and become more and more complex in the labyrinth of ducts, heating equipment, air conditioning, mechanical ventilation, and so on. You can also get these things by mechanical ventilation, but we prefer more natural efficient building with the hemp lime mixture. So we're going deep to that thermal regulation. So if the first concept is thermal bridge, you have to avoid thermal bridge. And if we look at our blocks and their values, thermal bridge can be covered by the material. And if we look at the norms, they all fit the norms for linear heat loss. So the V value, the F value is all, F value is above the norm and the V value is below the norm. So technically we can insulate all the thermal bridge. Another point is thermal regulation. We like to talk about thermal regulation, not only about insulation, because thermal regulation also has to do with the wall temperature. The lambda value only talks about conductivity. What important is that also the wall temperature will be kept as stable as possible, at least at 16 degrees. Because if the wall temperature go lower, it gives a sensation of cold. And if we have a sensation of cold, we have the reflex to increase the heating. So the most important is to keep it stable. Our blocks, they can absorb energy, store it, and give it back. So this means that storage capacity can keep wall temperature as stable as possible. I will explain later on more in detail how this functioned, but globally you can say a material which can store and keep so the heat or the thermal energy is more stable for in the wall temperature. So let's go more in detail. So here we have worked out a table just to compare things with other materials, very often used as insulation material. And then we have a table, and the first value is the C value, is the specific heat capacity in joules per kilogram Kelvin per degree Kelvin. The second is the mass, the weight, because it also has to do with the weight of the insulation material and the mass. The thickness, so we keep for all the examples the same thickness, just to compare. And then this is the QS, is a calculated value, is the thermal capacity. So the capacity, so the amount of heat a material can store with this thickness. And this, you achieve this by multiplying the C with the P and the E. And it's in joules per square meter Kelvin. And then we compare it with the lambda value we needed. This is thermal conductivity. So if we take, for example, concrete, you see there's a C of 1000. So this specific heat capacity is 1000. A very huge mass. It's 2,150 kilogram per cubic meter. Is a very high weight. We have a standard thickness of 15 centimeters. If we calculate that, you can see that concrete can store 322,500 joules per square meter Kelvin. But concrete has a very, very high thermal conductivity. So it loses all that energy in 8 hours. After 8 hours, it loses that energy. So then we need an insulation value. Let's take glass wool. Glass wool has also a specific capacity, but it's very lightweight. It's only 30 kilograms. With the same thickness, we can calculate it only can store 4,635 joules per square meter. But glass wool has a very, very low thermal conductivity, so it gives it away very, very slow. It keeps 6 hours. So if you compare this with this very low mass, it can keep it at least 6 hours, that energy. So we have to combine the both goods of both worlds. So if we can combine a material with a high mass and a good lambda value, then we can store a lot of energy. Then we go, and this is where we go to the hemp blocks. Hemp blocks has a capacity of 1,600, and this has to do also with the water in the cells of the hemp. Has a very high capacity. The mass is 340 kilograms per cubic, the same thicknesses. If we calculate this, it can store 80,880 joules per square meter. And it has a good lambda value, so it has a very low thermal conductivity. So this means it takes 48 hours before all that energy goes out, and 48 hours is more than a day cycle. And so outside temperature changes in the 24-hour cycle. It changes. It goes 12-hour temperature goes up, and 12 hours it goes down. And so outside temperature it goes ups and down. But if you have a material which can store, then you can keep inside your insulation, your building, very stable from temperature influence from outside. But it also stores the energy from your heat pump, and it creates a very, very stable inner climate. And this is directly affected in your energy bill, in your energy consumption. The same it does with humidity. It takes water, it gives it back. It's a vapor permeable material. It has a mu value of 2.8, and the mu d or SD from 0.17 to 1 meter. So this is the diffusion equivalent air layer thickness. So it's a vapor open, vapor permeable material, and this with this material, the inner climate is kept very, very stable from humidity. When humidity goes up, the blocks takes it. When humidity goes down, it gives it back. So the inner temperature, inner moisture is very stable. It's a natural material. It's a lot of fibers, and fibers can absorb a lot of noise. And also with the mass of the lime, you have two kinds of noise pollution. The one is the resonance, and the other is reduction. So if there is a lot of noise in room 1, and you want to protect yourself in room 2, the other side, so in this side, you can you need a protection, and the blocks can reduce 37 to 35 dBs. Other effect is resonance, and it takes 85% of noise pollution can be absorbed in the material, so it absorbs the noise to reduce resonance. Last but not least, fire resistant, as I explained in the beginning, it's due to the lime, every fiber, hemp fiber, the fiber itself, the hemp fiber, it burns very quickly. It's like straw, but it's covered all over by a thin lime layer. And this means that when there is a flame on it, it only carbonite. It don't burn. You can't burn it. And for fire protection, there are three different measurements taken in the test. It's how long your structural will sustain if there is a fire and there is a loading on it, how long it will sustain, how many energy is radiated or goes through and will it burn or will it not burn. So as I explained before, it can absorb a lot of energy. So a lot of also the fire energy will be absorbed in the block first and then goes through. So on all this, it's very, very high performance, and we can go with the new tests we have tested. We can go up to 240 minutes of fire resistance with one side plastering on it with the 30 centimeter blocks, and the 20 centimeter blocks will go up to 120. So we jump into more practice. So yes, how do you work with the blocks? So now I came to explain the properties, but it's also nice to know how you make a wall. So it's a masonry system. And yes, to start, there's one thing you have to take care of. The block has to be protected against a capillary rising moisture. And you can apply a sealing tape, DIBA, and go up 2 centimeters. The first layer is always in a mortar, in a normal masonry mortar. And for the first, obviously the upside going, there you use our lime mortar. This is very thin. So the first row, you have to take care that it's perpendicular and flat. You use cement instead of the lime mortar. And you spread a bed of 1 or 2 centimeters thick. This has to do also with the adjustment. Just see if everything is straight and perpendicular, flat. If you use outside insulation, the hempcrete or the hemp block should always have to be 15 centimeters above ground level. So then you use a foundation of normal cellular concrete, or you use our angle for the connection, so angle profile. Then for the next row, you can go on with the adhesive mortar, and you can to abrade the high points with the rasp. We have a special rasp to make it flat. Then you glue horizontal and vertical joints, very thin, only 3 millimeters. So you place block on the 3 millimeter fresh mortar, and you always have to work with staggered joints. This is also like normal masonry, and so it should have staggered at least 20 centimeters. But this is also a normal masonry technique. Remove excess immediately because the line becomes very hard, and afterwards it's not easy to remove it. And if there's a lot of lime, not a lot of glue in it, it can give to phantom joints in your plastering system. So remove it immediately, and you don't have to fill it up. Just glue it, and that's it. At the ceiling, you leave maximum 2 centimeters, and then you can fill it with hempcrete or with a flexible insulation or with a bounding foam. So, but not more than 2 centimeters of join, and then the last centimeters you fill it with hempcrete or flexible insulation. Cutting is very easy. So small blocks you can cut with a normal hand saw. Bigger blocks, or if you have to do a lot of sawing, we advise an alligator saw. It's with two blades, an alligator saw with the saw for aerated concrete with hardened teeth. Larger works, or if you have to cut in edges, then we advise a band saw, because this goes most quickly and you can have very clean, very straight perpendicular cuttings. So if you have to fix the new wall to a masonry stone or concrete masonry, then you use the masonry hooks to make the connection. If you have to fix it against wood or wood-based products, you need the connection bracket. You screw one in the block and one in the wood, and then afterwards it's glued, so it's fixed by the glue. We have also a system of filling for doubling our existing walls. Then you leave a cavity. I come on later on in detail. So you leave a cavity and you fill it afterwards with the hemp lime mixture. It's a hemp lime mixed but dry, afterwards dried mixture to make to have a quick filling. So here you see in practice how it is filled. This is just good to have good connection between the inner block and the existing wall. We also offer a few accessories, lintels. If you have windows or opening in the facade, you can use our prefabricated lintels, and it goes up to 3 meters. So this is the limit for the opening is 250 centimeters. So because also the lintel has to be staggered for at least 20 or 30 centimeters. If it's not possible to use the lintel, we have also special brackets for bay window passage. The carpentry can be fixed directly in the blocks. You can make a cutting to cover a little bit also your window to avoid thermal breaches from the carpentry, the frame. So all this is possible. You can groove and clad or make some to make the fixation of your installation and directly in the blocks. And we also use the blocks for floor insulation. Okay, let's go to applications, how it is used in practice. As I said, it can be used for an insulation high performance shell. You can use it in renovation and new buildings. Renovation, the original wall or facade can be preserved. There is no condensation, insulation on the inside. There's no condensation issue because the block can absorb a lot of moisture from condensation and keeps it stored in the block and gives it back to the inner climate when it's needed. And so you can keep the existing building, but with an increased comfort, and there's no need for a vapor barrier. New constructions, it's a transparent and homogeneous envelope for single wall constructions, and it's only one system. As I explained, it solves sound, thermal regulation, moisture regulation, and it's very rapid. The hemlock is self-supporting but not load-bearing. So this means that you can build self-supporting in between two beams, but you need a post and beam system to support flooring and roofs. So because it's not load bearing. So that's why we developed the Hempro system, because that skeleton can be wood or concrete or steel. And if you want to use concrete as a skeleton in the post and beam, then we have developed the Hempro system. And it consists of a range of adapted blocks. So this is the U block, the pre-drilled block, the pre-drilled block, the Hempro, and the full block, just for the self-supporting part of the skeleton. And the partition block, this can be useful to hire a beam. And also we have the normal lintels and the skeleton, the Hempro is used for the beams, and the pre-drilled blocks are used for the columns. So let's take a look at a normal drawing. So that's what we do as a pre-study. So this is a pre-study. We can help you to know where to put the beams. Afterwards, it should always be recalculated by a local structural engineer. So this is just an option that we offer. And here you see we can indicate, okay, here you have to put the beams to make it stable. Sorry, the posts, the columns, and here should be the beam, the internal beam structure. And then your structural engineer can calculate if it is enough or if it is stable with this pre-study. You see more in detail how it's connected to the foundation. And you see here the steels coming from the foundation directly to fix it. Here you see the detail 20 centimeters above ground level. This is with an insulated concrete floor, and this is with a normal concrete floor with insulation afterwards. So the insulation is above, and here is the insulation beneath the flooring. But we also have a guide with all those details in it. This is more a massive foundation, but that we can advise you personally which system should be used. This is with a more massive foundation, but again, it's the same system. You need a connection between the foundation and your columns. If you pour the concrete in it, it's a lot of pressure, so you need to protect it in between that pouring, and afterwards it can be removed. This is a manner you can do this way, or there are also other possibilities. This leads us to the maximal panel size. This is the maximum height free, not load bearing, but the maximum self-supporting height panel size. So for the 9 centimeter blocks, it's only 2.5 meter. For the 36, you can go up to 8.5 with the connection above and under. This is the maximum panel size. If you need a dilatation, that's because in your construction, sometimes you need dilatation. Then we have a special bracket to fix the dilatation. For example, on a ceiling or on a connecting wall. It's a special flexible bracket. So this is in a wall, in a long wall, for example, if you need dilatation. If you need a fixed connection, so if you don't need, mostly you don't need dilatation, you can use our normal Ikili 08 or Ikili 14, just to make a fixed connection between the blocks and a wooden construction. We also have, if you use, for example, in your construction, metallic structure instead of concrete structure or wooden structure, metallic structure with the IPA system. Then we have special connecting brackets, and it's used Achille IPA just to make a good fixation between the block wall and your structure. So this is a very quick, I know it's very quick technical review, but we have from time to time all specialized webinars to go more in technical details. So let's finish with take a look where it's used in practice. So we go to a few references. This is a housing. You see also round formings. It's a system. It's a project in Germany, and with a lot of roundings in it. It was a combination of hemp pro and the wood post and beams structure. So it was a combination of both. This is in France with the hemp pro system. This is post and beam with woods. So the big difference between hemp pro and post and beam wood is with hemp pro, you make first the wall and then afterwards you pour in the structure. Post and beam in wood, then you first make the construction in post and beam wood, and then you make the masonry of the blocks in between the beams and all over the beams. So afterwards, finally. This is a hemp pro system in France. So here you see the reinforcement steel coming out of the foundation. This is the old system with the round. Now they are squared, the columns. So here you see the beam, the connecting ring beam all over, which connects all the posts, each stage. So you have it each stage. This is an office building. This is a new building in Australia, just for our Australian friends. In Israel, so we see all over the world. This is a very nice post and beam system in Denmark. So again, post and beam, here you see part of the structure. And then afterward, the filling in between. And in this case, also a filling all over the beams. This is in the Netherlands. Here you see have a nice detail of the post and beam in wood. This is with laminated post and beams. And the fill-in with concrete. This is the project in the Netherlands. Here you see the stabilize, and you build first the post and beam structure, and then afterwards it is filled in and finished. Here you see at the inside. And let's go back to this one, because you see it's a wooden cladding. And this shows also the importance of the heat storage capacity of the blocks. This is a wooden construction, very lightweight. If you insulate this with lightweight insulation materials like glass wool or the insulating foams, with that black, because it's all black, a lot of windows, it will in summertime hard bearing to be there. In a temperature will go up very quickly, and you need cooling at that moment. But here, if you have screens for sun protection, with all the mass of hempcrete in this house, so the owner of the building, which is a famous Dutch metallurgist, he says, okay, even in summer, you don't need cooling, even with the black facade, because black absorbs the heat And also in the Netherlands, the summers can be very, very, very hot. So he says even in summer, inner climate remains about 22, 23 degrees without active cooling by air conditioning. So this is just to show importance of that thermal storage capacity of the hemblocks. So you take a look at, so he left the post and beam apparent, so also a layer in between and a layer outside. You can combine it with timber frames, normal timber frame construction. Then you use it often as a outside layer or inside layer, and the flexible insulation in between the beams, because the blocks are not flexible enough to work in between beams. You can combine it with CLT. CLT structure is massive wood construction as an outside layer. Here you see it more in detail. This is in London, combination with metallic structure. Metallic structure. Here you see at least 15 centimeters above ground level. After all the layers of blocks, you don't see any more the metallic structure. You see the EPA, a renovation in Italy. France. And this was amazing. This is a school in Belgium, OPEC. Just also for the inner climate, it was a primary school, new building, and if you look afterwards, it's a very natural environment, a very healthy environment for the children in it. And here also, there is no air conditioning. There is just a very, very good environment for the young children in that school. And this was also the goal of the architect and the school. This was Box in a Box in Belgium. It's public renovation. Here the blocks were used to keep humidity at a stable. It was at a stable level because it was for patrimony. It was for historical things to protect them against. It was a depot for old documents and things like that. And inner humidity was an issue, so that's why they construct a box in a box with the hem blocks to maintain a very stable humidity at the inside. So I go a little bit quicker because we are running a little bit out of time. Here you see a renovation with the dry filling in between the old wall and the new wall. It's co-housing, 26 old building reuse as 26 houses. Here you see the dry filling in between. You leave a cavity of approximately 3 centimeters. You make the masonry 3 centimeters more at the inside. You leave a cavity of 3 centimeters, and then afterwards you fill it with the dry hemp lime mix. And we call it the HL mix, HL mix. And then you can renovate old buildings, also inside renovation. Nice pictures. You can also use the blocks at the outside. This is outside renovation. Then you don't make a shell of blocks at the inside, but you do it at the outside. It's also possible to maintain your old construction on temperature. Then it's the same system, masonry, always 15 or 20 centimeters above ground level, starting with the blocks in between normal insulation, waterproof insulation, and plastering. This is a very nice wall insulation in Canada. And you see the roundings. It's very, very beautiful because the blocks, you can mold the blocks like it's clay. You can make every form you want. So for architects, be our guest. So here you see a quick look at our international partners. And also many thanks for UK Hempcrete. They have done a lot of promotion also for this webinar. And also many thanks to all our partners. Just a quick look, Havenes Handlers is for Denmark, Hembuild is for Ireland. So I'm sorry, I don't know where Harcolime, but perhaps Julie can fill it in.
Yeah,